Hi guys, in this video I'm going to discuss about the starters 133 Codechef competition. And in this video, I'll discuss about this problem ABC conjecture, which I didn't have time to look into during the contest, but I have able to solve it now. So let us get into this video. In this problem, they have given us a string S of length n, and the string S contains only the characters A, B, and C. So literally only three characters A, B, C, and it can be of any length, which is length n. And what we need to do is we need to modify the string s by choosing three indices, any three indices I, j, k, where I is less than j is less than k, and and we need to choose three indices I, j, k, and I should be less than j should be less than k, and S of I should be A, S of B, S of I should be A, S of J should be B, S of K should be C. After choosing like this, we need to remember, again I will repeat, we need to choose three indices, and in that three indices, one should be A, first one should be A, and next one should be B, next one should be C. Doesn't matter that it these are consecutive indices, it can be anything, but first you need to choose A, next B, next C, and after that you need you can either delete you can either delete Si or Sk. You can delete either A or C. That's what they're saying in the second point. Delete either A or C from S, that is either indices I or K. After deleting it, either of them, not both of them, either of them, then what happens? Length of the string S reduces by 1. Obviously we are deleting one of the character, right? And the main thing comes here. What we need to achieve is we need to find minimum number of moves that can be made on S, such that it's impossible to perform any further moves on the resulting string. Basically, let's take this example. They have in the C, B, B, A, C, B, A, C, C, right? We need to choose three indices I, J, K, and one should be A, next should be B, next should be C. So I'm choosing this A, next this B, this C. Only one of them, the only this combination is there right now. After choosing that, I can either delete A or C. If I delete A, what will happen? C B B C B A C C, right? Or if I delete C, what will happen? C BBA CBAC. Either this can happen or this can happen. If you look at this one, this came by deleting C, this C. And again, I can perform this operation IJK, A, B, and C. I will choose this A, this B, and this C. But here, I cannot perform the operation. I need to have B in the middle. I need to have A on the left hand side. I need to have C on the right hand side. If I keep B in the middle, any B in the middle, I will be having, I'm sorry, here I am having C on the right hand side, but I don't have A on the left hand side. So see, this is what we need to achieve, minimum number of moves. Just by removing A made the string impossible to perform any further moves. But if I have chosen this path, again I'm able to perform operation. So for this number of operations will be 2. For this number of operation required is only 1 to make it incapable of doing this operation. So we need to find the minimum number of moves. So basically, from this, what I can conclude is, one, I should have B in the middle. After having B in the middle, either I need to remove the A's from the left hand side, or I need to remove C's from right hand side. Okay. So for example, let me show you the subtest. They are given, if you see the input, the as usual the number of subtest t is given, and next line n is given the length of the string, and the very next line string is given. So subtest, length of the string and the string. So in this abcc, either I can be in the middle, either I can remove the a's on the left hand side, or I can remove the c's on the right hand side. So if I, which is easier, number of a's is less, number of c's is 2, number of a's is 1. So I can just remove the a's from the left hand side, so minimum number of operation is 1. So if I say the next one, b, b other, keep the b's in the middle. There is no a on the left hand side here, but c on the right hand side is 1, 2, 3, 3 other. But if I keep this b, 1, 2, 3, 3 other, but there is no c on the right hand side. So either of the b doesn't have, this b doesn't have a on the right hand side, this b doesn't have c on the, sorry, this b doesn't have a on the left hand side, this b doesn't have c on the right hand side. So the operation itself can't be performed. So minimum number of operation required is itself 0. If I see this one, aa, bac, bc, either we'll just solve without looking at the solution. aa, bac, bc, bac, bc. So either I can traverse from this side, this B in the middle, this has two A's, two C's. This B in the middle, this have three A's, but only two C's. So minimum number of operation, oh sorry, only one C on the right hand side. So minimum number of operations required will be 2. Why? Because you, either I can remove this thing for this B, and after this one, number of operation will become 3. Or else I can just remove the C's on the right hand side, number of C's were 2, so operations can't be performed anymore here. So just the minimum number of operation required were 2. So basically A's from the left hand side, C's from the right hand side, how will you write it in code? As I said in the third subtest, for A's from the left hand side you can traverse the array from the left hand side, and find minimum number of operation to delete the a's. And for c's in the right hand side, go through the array from the right hand side and find the minimum number of operation to delete the c's, and find the minimum of these two, and that will get you the answer. But but here there is one corner case. If you see this subtest, abb, ccc, aaa, bc, you might say that I'll go from left hand side. A's are like 1, 2, 3, 4, and I'll go from right hand side. C's are from 1, 2, 3, 4. So a number of A's are equal to number of B's. So minimum number of operation will be minimum of 4 comma 4, which is 4. Actually wrong. Answer for this string is 2. Why? Because if I remove this A and if I remove this C, which makes it impossible to perform the operation. So basically, number of possible conditions to achieve this problem are not 2, 3. So I'll show you the all the three conditions. One, remove the a's. Let's say we have a b c, right? A b c, remove the a's from left side, then it will become end of bc. Second one is remove the c's from right side, then it will become AB. Third one is remove A and C from both the sides and leave only B. Understood, right? Either if you remove A, if it becomes BC, you can't perform the operation. Why? Because you need three pointers. In the three pointers, you need to choose A, B, and C. If it has only BC, you can't perform the operation. Similarly, if you remove the C's from the right hand side, it will become AB. You can't perform the operation. If you remove A and C from the both the sides, this C and this A, and it is left with B in the middle, again you can perform the operation. Why? Because you don't have the two pointers, only one of the pointer, and you can perform the operation. So the possible number of conditions are three. You need to find number of a's in the from the left side, number of c's from the right side, and also this part, and find the minimum of all three. If I show you the code in this, just have a prefix array for the A and keep on incrementing the prefix from the previous value. And similarly for C, you can have a count variable. And once it hit B, find the minimum of the answer. What is answer here? Int max. It will be keep on updating. That answer is what we are printing out, and minimum of answer versus result plus prefix of I, and result will be the count, and finally print the minimum of answer comma result. Basically it is just the elaboration of these three conditions. Thanks for watching this video. Thank you.